Hi team, Mr. Rator here. Right, continue with question 11. This is standard form also. So the best way to tackle this question without a calculator will be, first of all, do 7.5 times 2.5 times 10 to the power of 4 times 10 to the power of 3. Okay, so put them all as a long multiplication, but the numbers here and the powers to the 10 here. Now, 2.5 times 7. If I times 7.5 times 2, that is 1.5. So if we just write that's going to be 15, sorry. 2 times 7.5 is 15, so let's just write 15 here. And half of 7.5, well, half of 7 is 3.5. And half of half is a quarter, so 0.25. So if I add all this up, I'll get 7.5 here, I'll get 18.5. Right, so that's going to give me 18.75, and what I could do here is keep the base the same and add the powers, which will be 4 plus 3. And they are going to be times in. So what I'm going to end up with is 18.75 times 10 to the power 7. So we've got 7.5 times 2.5, which is 18.75, and 10 to the power 4 times 10 to the power 3, and base is the same, keep the 10 there, and add the powers. 4 plus 3 is 7. Now, you'll get a mark for this, but it's not standard form. Standard form is where this number has between 1 and 10. So we need to put a decimal point. Where should we put it? We've got to put it there. So we've got to make this 10 times smaller. That will be 1.875. Now, because we made that 10 times smaller, we have to make it times it by 10. Okay, so by times that 10, that will turn it back to 18.75. So that is obviously 10 to the power 1, because it's just itself, and multiplying that by 10 to the power 7. Right, so standard form, we will have 1.875 times, and there's 1, the base is the same, there's 1 and 7, so multiplying, we add the powers, so that would be 10 to the power 8. Done. Okay, clear that. Let's scroll down. Let's get to the next question. Okay, so question 12, another standard form. Let's just have a quick read. An object is traveling at a speed of 2,650 meters per second. How many seconds will the object take to travel a distance of 3.45 times 10 to the power 10 meters? Give your answer standard form corrected to significant figures. Okay, so already looks like a calculator. So what we do is, first of all, we got distance, speed, time triangle. The distance goes at the top. Speed, time. I know the distance is this, and I've got the speed is this. So it takes how many seconds? Time. So time is going to equal to distance, which is 3.45 times 10 to the power 10 divided by speed is 2,650. So if you do that in your calculator, I'll just type it as it is, get the fraction button going. 3.45 times 10 to the power 10 over 2650, and you'll get an answer on your calculator, which will be 1,3 0, 1, 8, 8, 6, 7, and 0.92, etc. But we just wanted to see significant figures, so before we do anything, let's just 1, 2, 3, comma, 1, 2, 3, comma. So that's to the nearest million. So this is approximately equal to 13 million. Okay, 1, 2, 3, comma, 1, 2, 3, comma, 13 million. So this is how many seconds, and if I put it in standard form, we need to introduce a decimal point, which will make this 13, this number here 13, between 1 and 10, so 1.3 must go in the middle, multiplied by 10, and how many times am I going to jump this? Well, if I want the decimal point going to the end and I start here, how many numbers are there between that decimal point and that? So I've got 3 there, another 3 there, 6, and 1 there, 7. So that's going to be 10 to the power 7. Okay, job done. So again, to recap, use the distance time, time equals distance over speed, put this through to your calculator, get a number here, round it to 2 sigma figures, which is the second sigma figure here. This 3 stands for millions, so that's to the nearest million, which makes it 13 million, and then we just go about writing it in standard form, which, yeah, give you answer in standard form. Okay. Question 13. Let's just quickly forgot question 13. Write down the value of 10 to the minus 1. Well, we discussed this before. Anything to the power of a negative, that can become positive once brought to 1 over that power. So it's 10 to the power now. Instead of minus 1, this will become positive 1. 10 to the power 1 is just 10, so that's 1 over 10. You can leave the answer like that, or if you want to write this is a tenth in decimal is 0.1. 1 mark, so that will be correct. Or that. This one, basically the way I do this is when it's a fraction as a power, the top number I call the actual power, and the bottom of the fraction I call the root. So this 3 here at the bottom means cube root, and the 2 there means the power squared. Okay, so if I do the rooting first, so I'll get 27, and I cube root that, then put brackets around it, and then put the square outside. So cube root of 27 is 3, because 3 times 3 times 3, 3 times 3 is 9 times 3 is 27. And then if I square that 3, which is 3 times 3, is 9. Okay, it looks really complicated, but once you get the hang of it, noticing that is the power at the top. Well, it's the whole power, but we'll take the 2 as an integer power and the 3 of the fraction, make the denominator as a root. Okay, so this is now surds, introducing surds, and it wants it in the form of k3. Okay, root 3. So what we could do is straight away try and see how many 3's go into 75, which is 25. 23 plus 25 is 75. So straight away I could do 25 multiplied by 3 and square root the lot. Now, when you got square root and it's a multiplying, you can split that up. So what we can do is we can write it as 25 root square root. Sometimes we just call it root, and root 3. Write that, so we split them up. Now the best thing about this is square root of 25 is 5. It's a perfect square number which we can square root and get an integer out. So that will be 5. And root 3, we can't do nothing with that, so that will be left as 5 root 3. And therefore, where k is an integer, in this case, therefore k is equal to 5. Bingo.